Okay, so we want to prove that the remainder in the Taylor series of cos x at a equals to 0, so if you expand at 0, is convergent to 0 as the number of terms tends to infinity. And you want to do this on the full real set. So we want to prove that the remainder is always convergent to 0, regardless of how big of an interval we're looking at for the possible values of x. Okay, so we'll start off first by saying, consider cos x expanded at a equals 0 on the set minus or to or, i.e. you have fx equals, what's the Taylor series now, 1 minus x squared over 2 factorial plus x4 over 4 factorial, etc., 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 and then you have a remainder term here, or k. Now, note that for Taylor, there's a bound on the remainder, that it will always be less than or equal to m times or power k plus 1 over k plus 1 factorial, where m is the maximum on the set minus or to or of the k plus 1 derivative of our function. Now, the maximum here is the maximum on minus or to or of either plus or minus sine or cos, because if you differentiate cos, you're going to end up with either sine or cos plus or minus, and so clearly that maximum is 1. So that means that the remainder term will always be less than or equal to r power k plus 1 over k plus 1 factorial. Now the limit as k goes to infinity, that means that this piece here will go to 0, because that's what we proved yesterday, except instead of k plus 1 it was just n, but you know, you could just say something like let n equals k plus 1, and then you can see quite clearly that this is literally the same thing as yesterday, or n over n factorial, that will go to 0. So or kx converges to 0, and what's interesting is that this is regardless of or. It doesn't depend on or, where or is a positive number here. So then that would mean that the remainder converges to 0 on or for cos x on the reals when you expand at a equals to 0 then.